So yesterday we were talking about 2072 and 2074, right? What happened in 2072? And 2076, I think, right? In 2076 there was lockdown. 2072 there was blockade because India blocked those entry points, right, and did not supply many more items. It was a bit difficult. It was blockade. But I was saying at the time lockdown, right? And you also became a little bit confused. Lockdown during COVID time and blockade by India during 2072 when new constitution was promulgated. Then the situation was occurred and it was a bit difficult also, right? Okay, children, what are we discussing? We are discussing the chapter force and motion, and we discussed yesterday about four equations of motion, right? What are the four equations of motion? First one, v equals to u plus at. What is the first one? V equals to u plus at. Second one, s equals to u plus v by 2 times t. This formula must be remembered, okay? Third one, what is the third one? S equals to ut plus half a t square. Fourth one, v square equals to u square plus. Actually, these all formulae, they are applied when the body is moving in horizontal position in a straight line, right? But if some bodies are falling from some height, then what are the formulae, that also we are going to discuss. And here are something to remember. How many points are given here? Four. What is the first point? Read together. So, if we throw something upward, at that time, the final velocity will be how much? 0. Initial velocity, there is value, but final velocity, 0. And the value of g will be negative. If we are throwing something upward, then the value of g will be how much? Minus 9.8 meter per second square. G means acceleration due to gravity. G means acceleration. So if you drop something, any object from certain height, then what is developed in it? Acceleration is developed. If a body is falling down, automatically what is developed? Acceleration is developed. That acceleration is called acceleration due to gravity. Why? Because that acceleration is produced because of force of gravity. What is gravity? What is gravity? That is the force of attraction of Earth or any other heavenly body. It is due to magnetic field. No, magnetic field, it attracts magnetic bodies, right? That is the ability. Like Sir Isaac Newton, he was the person to give this technique or idea. Any bodies in the universe, they attract with each other. Like there is Dex, here is one body. Mr. Neupani's body is here. There is attraction between these two bodies. That force is gravitational force. What do you call? Here is pen. If it is hung, then in between the pen and other bodies, what is there? What exists there? Force. Attractive force, that is called gravitation. But if the body is very big, massive, like planet, stars, their force of attraction is very high. That force is called gravity. Because of gravity, the things cannot go or escape away from it. But you may say, sir, what about rocket? Rocket goes out because it produces that force which is more than pulling force. Its escaping force is more than pulling force of. If no gravity, then what will happen? Flying means not flying. Not flying. No gravity means where to go? Nothing. Nowhere. Stay in one place only because nothing is pulling. Like in space, if you go near about 1 lakh kilometer up or 5 lakhs kilometer up, there is no any gravity, and the body will remain there only. It must be attracted, no, by some other things. That is the thing. So acceleration produced because of gravity is acceleration due to gravity. When we throw something upward, its value will be negative, and generally we take the value of small g how much? Minus 9.8 meter per second square. Right? What is second one? Second point. So when we drop something downward, then initial velocity 0 and the value of g also positive. Okay. Now make your concept clear. You throw something upward, final velocity 0, value of g negative. Drop something downward, initial velocity u 0, value of g positive. So if something is dropped down, then the value of g will be 9.8 meter per second square. Here was minus, but here is plus. Right? What is thought number 1? Point number 3. Retardation. Value of retardation is always negative. So if something comes, okay, if you say retardation, then value will come in minus. Okay. Fourth number. Yeah, it was discussed yesterday also, no? Altogether, how many quantities are there? 5. How many are there? What are they? S, U, V, A, T. What is that? S, U, V, A, T. Your posture must be correct. Make backbone straight. Now you have got straight backbone. It's okay. Later on it will be bent one. Then how can you make it straight? That's why while sitting, please sit with correct position. The backbone should be always straight one. So you just bend time in again, and later on you have to visit doctor. More time and more time. Only visiting doctor, that is not the solution. He or she gives you some ideas only, and you have to apply for a long time. That's why make every time your backbone straight. Right? Here is one question. It's already discussed, right? I gave you this question also. Question number 2. Will you read here? What is given? From where it came? No, it came, right? Please read. What is the question here? What happened to your sound? No sound is coming. Hello, boy.
The ball is thrown vertically upwards with a velocity 20 meters per second.
These are numerical problems we have to remember. A ball is thrown vertically upward with means that is u. U is how much? 20 meter per second. Use your logic. When we throw something upward, value of v will be how much? 0. V is 0. And value of g will be negative. G is how much? Minus 9.8 meter per second square. Okay, before that I have to remind the formula related to falling bodies. So V equals to U plus GT. What formula is there? If somebody is falling or if somebody is thrown upward, at that time we don't write V equals to U plus AT. What do you write here? V equals to U plus G. G means acceleration. Another is S equals to U plus B by 2 times T. Same thing. But we don't write S. What do you write here? H, height. Or H equals to UT plus half GT square, or B square equals to U square plus 2GH. These are the equations of motion for falling bodies, or for those bodies which are thrown upward. What are those formulae? Number 1,
V equal to U plus GT.
say it in your mind. What is the formula? V equals to U plus GT. Second formula? H equals to U plus V by 2. Third formula?
H equals to U plus half G square.
Fourth formula?
V square V square plus 2H.
Write down in your copy. If you write, then it will be set in mind. Otherwise, it will be Netflix. Watching movie, and when you come out, what is watched, what was there, no idea. That's wrong. Okay, Nikki sir. And look at this girl. Her name is Krizal Khanka. She has already managed such type of sticky notes. This is the technique, which are important things. If you write and paste in the book while reading, it gets open itself and it gives you some idea what it was discussed. It is a kind of memory, right? So please manage sticky note. I think Swarnima also has managed sticky note, right? Or it was already pasted there? Oh, it was already pasted. Okay, so these four formulae you must remember. V equals to U plus GT, H equals to U plus B by 2 times T, H equals to UT plus half GT square, and B square equals to U square plus 2GH. Now I'm going to rub it out. If complete, it's okay. Otherwise, also okay, because we have to go further. And this numerical problem contains maximum 3 things out of 5, and you can find out other 2. Okay, let me rub it out this one. Very simple idea. Now we don't need duster as well. So in this question it was said a ball was thrown upward and we have to calculate total time taken. So to calculate total time taken, what you have to do, you have to multiply the time 2 times, because to go upward it takes some time, again to come downward also it takes similar time. That's why double if you do, it comes here. Here are numerical problem. Later on I am going to provide you. Next one is, sorry.
One is proof that how much it takes time to go up, it will take that time to
Come down, right.
Why?
Why? Because the acceleration remains same. Acceleration of falling body or thrown body, it is same. For those bodies which are in the horizontal way, acceleration may not be same, isn't it? But in this case, earth doesn't say, oh, for this much body I will apply this much force, for another body I will apply. Not like that. For all bodies it applies equal force, so acceleration produced on each body also will be same. Okay, all right. Okay, children, this was discussed yesterday, and Arina is waiting. She wants to present her slides, because if the person doesn't get chance, also becomes very upset. Once again, let's do a recap. So I will take more 6 minutes. Okay, by 8:30 I will complete the slides. And what is the next heading, children? Inertia. Actually, inertia is property present in the body at rest or motion. Property present at the body at rest means it remains rest forever. Or property present at a body which is in motion means it remains in motion forever. That is called inertia. So what is the definition of inertia? Property of a body because of which it remains or tends to remain in the original state of rest or uniform motion on a straight line, unless we apply force from outside. External force means we apply from outside. So next thing is relation between mass and inertia. Relation between mass and inertia. Have you played swing or not? During the time of Dasai, we play. Like there is a person of 500 kg. Oh my God, 500 kg person. There is no. These wrestlers are also near about 220, 240 kg only, right? Yeah. and there is Anmol Adhikari. In one swing, who is there? Anmol Adhikari. Another swing, who is there? The person with mass 220 kg. Both are at rest. Both are at rest. Now, if they want to play swing, they must come in motion or not. And somebody is asked, okay, Anmol also asks one person, another also, that Mote also asks next person, please push me. So both are at rest. Now we have to bring them in motion or not. So who needs more force?
220.
Anmol or that Mote? Right? So more mass, more force means more mass means more inertia also. What is that? More inertia also. Less mass means less force, less inertia. So here what can we say? Mass and inertia, how are they related? How are they related? Mass is directly proportional to, what is that? Inertia. Okay, the relation is like this. A body with 5 kg mass and a body with 70 kg mass, which contains more inertia? 7 kg mass, because we have to apply more force on it. Deepak, he rides bicycle. What do I ride? Bike. We are traveling, and he also touches a person. I also touch a person. Now, who will get more hurt? The person who gets struck with bike or bicycle? Bike. Why? Bike has more mass, bicycle has less mass. So here we have to make concept clear. What is the relation between mass and inertia? They are directly proportional to each other. They are directly proportional to each other. So more the mass, more the inertia, less the mass, less the inertia. How many types of inertia are there? There are 3 types of inertia. What are they? Inertia of rest. Second one, inertia of motion. Third one, inertia of direction. Only this much I will discuss, and I will give this stage to Harina. Oh, check here. One experiment is given. What is here? Children, what is this?
Glass.
Glass. Glass tumbler. And here is rectangular paper, and here is coin. 3 things are given, right? And this coin, glass tumbler, and this rectangular paper, at the beginning they all are in rest. In which position? Rest. If you hit the rectangular paper, then what will happen? Paper goes somewhere else. Paper comes in motion. Comes in motion. But the coin goes inside. Why? Because when we hit the paper's position changes. It changes into motion. But the coin is still at rest, so it falls down. So that is example of inertia of rest. What the definition of inertia of rest?
Yeah, rest is the property of the body by virtue of its physical state in the state of rest based on its external forces and
Yes, it is the property present in the body at rest, due to which it cannot change its position itself. Right? So here are some examples we have to remember. What is the first example? When we stand or sit loosely on a bus and the bus suddenly starts to move, we jerk backward. We jerk backward. Yesterday also we discussed this one. Number second, when a blanket is given a sudden jerk, the dust particles, because blanket comes in motion, but the dust particles are still at rest, they fall down. And this is already discussed. Yesterday I told you another example of Mr. A, whatever, who is very weak in study and just struggling on study. Stand up, catch it. Sincere student, they just pay attention here. And you take tension on study. Apariyar, he was absent for 3-4 days also. Why? Why absent? Next day onwards, if you remain absent, I will just keep you in below classes. Stand straight. He is not fit for this class, I think. Look at the hairstyle also. Somewhere else, very bad. This one, inertia of motion. What is the definition of inertia of motion? Property present in a body at motion, due to which it cannot change its position automatically. It remains in motion. How many examples are here? What is the first one? Seat in moving bus jerk forward when the bus stops suddenly. If it stops slowly, no problem. But sometimes the driver applies brakes very quickly, right? He jams on brakes very quickly at the time. Sometimes they may go out. Especially we have noticed in South Indian movies like this. Driver applies the brakes. Many persons they come out from that front window. Have you noticed that? Very interesting thing. How do they shoot also? Right? What is second one? A coin thrown vertically upward in a moving bus comes back in the hands of thrower. In a moving bus, if you throw some coin up, it comes down. So we have to try with less money only. 1 rupee coin, 2 rupee coin you try. In the market, we can get 5,000 rupees coin also, 60,000 rupees coin also. Nepali.
And it works.
Yeah, why not? That is special coin made of gold and silver. Gold and silver. He was just confused. So it's not found everywhere. To get that, you have to go to Nepal Rashtra Bank, Central Bank in Thapathali. So pay 50,000 rupees, get a small coin and come. Maybe 5 gram. 5 gram also, I think we don't get. Because for tola, the gold is now near about more than 1,50,000 rupees.
1,75,000.
The 176 that for means which is made with the ornamental one, but only coin it is cheaper. Okay, and athletes runs for some distance before taking a long jump. And what is the last one? Inertia of direction. What is the definition of inertia of direction?
The property of the body.
Property of body by virtue of which it maintains or tends to maintain its direction. Motion unless motion. How many examples are here? When a running bus suddenly takes a turn, the passengers experience a jerk in opposite direction. When the bus takes turn in left side, they just move towards right side. Have you got this experience? Or if the wind is open, directly outside. South Indian style, right? What is second one? When the wheel rotates at a high speed, the mud is sticking to the wheel flies off tangentially. So, my motorbike, sometimes if I make it on and then allow that back wheel to rotate fast, then wheel rotates one side and the mud goes in another side. Tangentially means making 90 degree. How much degree? 90 degree. Okay, that is all about inertia and types of inertia. How many types of inertia are there? 3 types. I should like that info. You jungle it. How many are there? 3. 5 are there. One more. What are 3 types of inertia? Inertia of rest, inertia of motion, inertia of direction. One example of inertia of rest.
If the bus is start quickly,
When the bus starts quickly or suddenly, then the passengers fall backward. Inertia of motion.
when the
Bus stops suddenly
passenger
forward. And third one, when a running bus suddenly takes a turn, the passengers experience a jerk in opposite direction. Give a big round of applause. Now I'm going to welcome on the stage then Miss Arina Gubaju. She's waiting. I think she has become too much tired by waiting. Ishandra is here, and she wanted to do yesterday's. After her presentation, children, after her presentation, there will be your note making compulsory. Otherwise, they are very Simple and making very less. Okay, welcome on the stage. Arina Govaji. What is it? Not coming?
Namaskar and very well good morning to you all. As you all know, it's me Aina Gubaju from grade 9 to present about Newton's law of motion, and it's the portion that I belong from group A, from chapter force and motion. And without wasting our time, I like to present force and motion.
You don't third law of motion, kids?
Yeah, I have from my practice from Newton's.
First, second, also this. So, please, you just go.
Newton's first law of motion. Newton's first law of motion states that every body continues to remain in its state of rest or uniform motion along a straight line unless an external force is applied on it. It means that first law of motion states that whenever we apply force to next object, then only the body moves or tends to move and change from the state where it is. Like if it is in uniform motion or rest, then it tends to change into a motion, and it means that the body continues to remain moving with a uniform motion on a straight line unless an external force acts on it. For example, if we pull a body which is in rest, then only it moves, and it is stated by first law of motion. And continuing it with Newton's second law of motion. Newton's second law of motion states that acceleration produced on a body directly proportional to its mass. Newton's second law of motion describes the relationship between force, mass, and acceleration. As for in first law of motion, that there is stated that external force when reacted on a body only that moves. Then in second law of motion, there is this description of force, mass, and acceleration and their relationship. And I would like to conclude this part and continue with Newton's third law of motion. The body exerts a force equal to its weight W on the surface. The surface in turn exerts a force in the upward direction such that R equals to W. The body always exerts a force equal to its weight. If the body weighs less, then it exerts less force, and if the body have more mass or weight, then it exerts more force. Newton's third law of motion states that to every action there is an equal and opposite reaction. It means that to each action or to every action there is the equal reaction or the opposite reaction, and action and reaction always act on different bodies. Both the action and reaction always act on different bodies. According to this law, whenever a body exerts a force on another body, the second body also exerts the force of equal magnitude on the first body, but to the opposite direction. And there are many events based on this third law of motion, and one is mentioned here. In order to swim, the swimmer pushes water backwards with his or her hands. Due to this reaction offered by water to the person, he or she is pushed forwards. We can even see while we swim in a swimming pool, the swimmer or us, we push that water backward through our hands and we move forward. And here is a figure of Newton's third law of motion, where for every action there is proof that for every action there is an equal and opposite reaction. Like while walking also, we push opposite towards the floor and we move forward, which where there is an equal and opposite reaction. And now continuing with elasticity and plasticity, the next topic. I'll first explain about elasticity. Elasticity is the property of a solid material by the virtue at which it tends to regain its shape after the removal of external force. Elasticity means that it is the property of solid material when the when that material virtue or tends to regain the shape it is before after the removal of external force. Uh, and our next topic is plasticity. Plasticity is the property of a solid material by the virtue of which it tends to retain its deformed shape after the removal of external force. And here is the example of elasticity with our next definition: the ability of an object or material to resume its normal shape after being stretched or compressed. Like we can even keep an example of a rubber band. If we pull it, then it changes its shape, and after again we remove the external force we applied, then it regain its original shape. And here is the plasticity example of plasticity. Here is a picture of deformed paper clip. And thank you for your attention, and I would like to conclude here. Hope you have a great day.
Thank you very much. What a lovely slide made by Arina Gubaji. Give a big do. We have to accept the good work of the people, right? And we must try to make our slides much more attractive so that people, they just pay more attention towards these activities, and it is more clearer as well. We have seen the slide of Jenny Sadara. We have seen the slide of Arina Gubaji. They belong to same group. Sadara, he wrote only definition and left. That is lazy bones. That is just formality. Sir said, okay, prepare slide, prepare. But Arina, she prepared with full interest. Oh, I must do this one. And the animation was also very good. Now look at here. Thank you for your attention. It's very nice, right? Okay, children. We have got near about 10-15 minutes left. Your duty is to make note on mainly three things. Number one, inertia, types of inertia, their examples. Yesterday I have given you question, but today you have to do such note making work. Second one is Newton's laws of motion, and when did Newton propound these laws, and what is first law? Example. Second law? Example. Third law? Example. All those things will be discussed in our next period as well, and we will do the question answers. Okay, so your action starts now and my reaction starts now, because action and reaction must go together. That is mentioned in Newton's third law of motion. Okay, thank you.